Hello, hi, and welcome to session 2. Now we have Andrei Gurtov. Andrei is a professor at computer science in Linköping University, Sweden. Previously, he was at the University of Oulu and the Aalto University, and visiting the International Computer Science Institute at Berkeley multiple times. He received his Master's Science and his PhD degrees in computer science in the University of Helsinki, Finland. Professor Gurtov co-authored over 200 publications, including 4 books, 5 IETF RFCs, 6 patents, over 60 journals, and 110 conference articles, and still somehow managed to find time to supervise 15 PhD theses as well. Professor Gurtov's research interests are in network protocols, security of vehicular, airborne industrial systems, mobile, wireless, and IoT networks, smart grids. He is an ACM Distinguished Scientist, IEEE ComSoc Distinguished Lecturer, and Vice Chair of IEEE Sweden Section. He received Best Paper Awards at IEEE CS NC 17, IEEE Globecom 11, and co-advisor for the Best Doctoral Thesis in Computer Science in Finland in 2017. He had served on numerous journal editorial boards and conference program committees, including IEEE Internet of Things Journal, MDPI Sensors, IEEE ICNP, ACM MSWIM, and IFIP Networking. Along with all of those things, he has been an amazing help and advocate for young engineers all over Sweden, and I'm very glad we have him here tonight. Ladies and gentlemen, Andrei Gurtov.
Thank you very much for a nice introduction. And we are currently working on white papers for 6G. And this presentation will describe how we use 6G and 5G in aviation. So first we will play out the slides, and then I will answer your questions. Hello, my name is Andrei Gurtov, and I would like to present a paper called Aviation Scenarios for 5G and Beyond. This is a joint work with some students from Linköping University and R8vSYP, which is a civil aviation authority in Sweden. This paper is a survey, so it primarily analyzes existing publications and standards. Also, as part of this work, we have been contributing to creating white papers on 6G together with all university in the topics of networks and security. The focus of this paper is on 4 different areas. First one on using 5 and 6G to secure data communication in aviation. Second is improving passenger services like internet on board. Third one is positioning of unmanned aircraft in challenged environments like cities. And finally, using unmanned aircraft as base stations for retranslating data. And we primarily looked at the well-cited sources. Of course, this new area, so some of the papers were very new. We started looking at the challenges in secure aviation data communication. It is well known that data communication is not secure in civil aviation. For example, messages exchanged as part of CPDLC, the controller pilot data link, are not encrypted or nor authenticated. Also, service messages for cars like passenger lists and so on are sent in plain text, so they are not protected from manipulation. And the systems like a DSB for determining the position of aircraft also can be spoofed. Like we have a second paper at this conference demonstrating an attack simulator for a DSB attacks. So it is clear that in the future these challenges must be addressed, and perhaps 5 and 6G could provide secure communication means for civil aviation. So let's have a look at what has been proposed to secure data communication in aviation. One of the attempts to secure a car system for delivering data to airplanes was called PACARs, or protected ACARs. It's a proprietary commercial system and used partly in the United States, but not much outside. One promising mechanism in 5G that can be used to steer data communication for aviation, at least on the ground, is called ultra-reliable and low-latency communication. It is a part of 3GPP release 16 and supposed to be used for steering machines and automobiles in a highly reliable and low-latency way. Like the round-trip time should be about 1 millisecond with 5.9 reliability. Of course, it's yet to be seen if it can be utilized in aviation. When the plane is flying, maybe distances will be big to antennas, but at least on the ground, it could be prove useful for airport control. Next, we look at how 5G and 6G can be useful in improving in-flight passenger services. Many flights now offer some kind of internet on-board service, but it is often expensive, slow, unreliable, and high latency due to use of geostationary satellites. 5 and 6G could help to improve that situation. Furthermore, on the ground, still significant number of luggage gets lost, so some system to track the baggage in real time could be useful. So the question is how to provide in-flight internet with low latency and fast speed at a low price. One option is to utilize ground infrastructure for 5G with beamforming so that the signal reaches typical flight altitudes of 10 kilometers or more for commercial airplanes. This also reduces the interference as the signal is directed towards the sky. Already, a company called GoGo announced first plans to build such kind of air-to-ground infrastructure for 5G. Of course, it works only over land where there is such infrastructure. What about if planes are over Atlantic and they need still to get a quick internet connectivity? Typically, there are many airplanes that are crossing the Atlantic or Pacific over popular routes at the same time, and distance between them is not great. Therefore, it is even possible to build an ad hoc network from the plane which is currently connected to the ground infrastructure near their land and hope by hope cross the basically whole Atlantic to provide internet services with low latency and utilizing ad hoc communication protocols. Such kind of ad hoc plane-to-airplane networks are experimental, and they also bring their own security challenges. For example, it is possible to perform denial of service attacks on our airplanes or try to intercept the messages from our planes and basically drop them so that the internet connectivity is disrupted. So currently, it seems like a reasonable combination is to use 5G for terrestrial connectivity over land and satellites over open areas like oceans. Regarding luggage tracking, the current systems with printed paper tags, it requires scanning by laser to be read. Bags can be still lost somewhere if they, for example, drop from conveyor belt. So some kind of more active radio technology, for example, using RFID cards for remote reading is already being tested in China, for example, by Huawei. as well as the 5G standards offer so-called narrowband IoT mode that can transmit signal to long distances with battery efficient way and provide possibility to locate luggage even for passenger over internet. Now about how 5G can help to provide geographic positioning of unmanned aircraft in tight spaces. Many unmanned aircraft on the market today, they utilize global navigational satellite systems, GNSS, for determining its geographical position. But it is challenging when flying, for example, in a forest between trees or between buildings on the street, where some buildings they can block the signal. So the drone, for example, can collide with building or otherwise get lost. One of the methods to improve positioning of unmanned aircraft in challenging environments are signals of opportunity. It's use of signals that are coming, for example, from analog or digital radio or TV towers or Wi-Fi access points with known positions. When it's possible to compare, for example, from which angle the signals arrive, what is the time of arrival, what is the signal strength, and then use it as a tool to help determine unmanned aircraft position. It's also possible to use beamforming and the position of 5G towers as a source of signals of opportunity. And based on triangulation and some math, it is possible to calculate the drone position. Another approach for drone positioning, in addition to signals of opportunity, is the use of unmanned ground vehicle. In this case, this ground vehicle can be located in a place with better GNSS signal reception and provide this signal or position to the unmanned aircraft nearby. In experiments, it was shown to provide more precise localization than signals of opportunity. Now a few words about using unmanned aircraft as 5 or 6G base stations to provide the signal to our users. In some areas on the land, it is difficult to build a fixed infrastructure. For example, if it's difficult terrain with mountains or rivers, or this area has been lately affected by natural disaster. In that case, we need to provide quick wireless connectivity, preferably so that people can use their existing phones and other devices to connect to each other and to internet, and provide fast network coverage in such challenged environments. In that case, it is possible to use several smaller unmanned aircrafts as flying base stations that can connect to each other and form kind of ad hoc network to provide connectivity in the areas, for example, with damaged land base stations. Second option is to use larger unmanned aircraft to provide direct connectivity to land terminals over from the air, and later connectivity to ground vehicle. There has been some experiments and testing also to use air balloons to provide base stations in the air. They can stay for a long time in a similar location using wind and altitude changes. For example, Project Loon from Google is probably best known. So far, we achieved only moderate speeds of a few megabits per second, which is not sufficient for 5G standards. To achieve high speed and efficiency, it is important to use beamforming from flying UA base stations so that the interference is reduced and security improved. Also, those on many aircrafts, we have limited flight time and battery capacity, so efficiency is quite important. UAs are generally faster to deploy than balloons and can be delivered faster to the right location, but balloons maybe can carry more weight and can stay longer in the air compared to UAs. Now we can present some conclusions. In this survey, we looked at various ways where 5G can be useful for providing data communication in aviation. We started with aviation data communication requirements like from cockpit, which is currently insecure, but could be made secure by using advanced 5G features like ultra-reliable low latency communication. Problem is, of course, that aircrafts are quite slow to change, and it's in general quite a conservative area. The second use is the use of small 5G tags, radio tags, that can be used to track luggage in real time over internet, even without possibility to scan it nearby. The third area we looked is about in-flight internet, so how ground 5G base stations could help to provide it on board, and how ad hoc networks can be used to provide internet in limited coverage areas such as oceans. We also discussed how unmanned aircraft can be used as flying base stations to provide connectivity in disaster areas and also areas with difficult terrain where fixed infrastructure is hard to deploy. So we compared balloons and drone types of aircraft. Also, 5G can help drones to position themselves better in challenging environments such as cities, where GNSS signals can be blocked. And in this case, we compare two approaches. One is based on signal opportunities, such as known location of 5G base stations, or use of unmanned ground vehicle as a translator to get the positioning signal. Thank you for listening. I can try to answer your questions in the live question and answer section, or please contact me by email so that I can get back to you. Thanks.
I can try to answer. Still quite big echo for me.
Hi, we have a couple of questions. Can ILS, instrument landing system, and communication with ATC during landing can be affected?
Yes, it has not been our research. Topic, but there is one research group in Oxford which tried different attacks on internet on ILS, and they showed that with some equipment on board, it is possible to cheat it quite easily. So they have demonstrated it in some simulations and experiments. So yes, it is not secure. Although we have, my group has not considered this aspect. We focused on data communication with pilots, so between the control tower and the pilot, which is called CPDLC, and also security of aircraft positioning system, which is called R8vSYP. So hopefully it answers the question.
And then we had one more question. We had quite a lot of people asking if it was possible to share the slides afterwards.
Yes, sure. I think you have a copy of PDF slides, so feel free to send to people who are interested.
Do we have any more questions from the chat room?
This paper will be presented at IEEE Digital Aviation Communication Conference in 1 month called DUSK 20.
Okay, great. Then I would like to thank everybody for joining us, and especially you, Andrei. This isn't the first time I've asked you to help out young professionals, and I'm sure it won't be the last. And every time you've come through with flying colours, and thank you for giving such a wonderful talk and being so generous and donating your time. And yeah, thank you so much for everything.
Thank you so much for this opportunity and attention to present at this nice event. Good luck, everybody.
Thank you. Now, we are going to have 2 more sessions. The next session on the agenda will be a panel discussion where we have some IEEE experts, or IEEE volunteers, both. And they will be answering any questions you might have, and they will be talking about all their experiences that they've had with IEEE. And then the final session tonight will be from Greece, our host section. And there will be a brilliant lecture on integrated lab on chip, biomedical diagnostic chips, which sounds also very, very good. So I would like to thank everyone for joining us tonight. And please continue with the 2 last sessions. Next session starts at 7:30. So you have 10 minutes to go and grab a cup of tea or stretch your legs. And then please come back and join us for the panel discussion with the IEEE volunteers. And of course, Greece section's wonderful speaker. Thank you all, everybody, for tonight. And I will talk to you soon. Bye-bye.